السلام عليكم ورحمة الله وبركاته. أسعد الله صباحكم جميعا. المرة الماضية بدينا بشابتر 19 شابتر 19 وشرحنا أول سيكشن اللي هو سيكشن 19.1 وحكينا فيه عن اللينير مومنتوم والانجلر مومنتوم. وإذا متذكرين لما حكينا عن اللينير مومنتوم كتبنا إنه اللينير مومنتوم هنعبر عنها بالرمز L وهي بتساوي الماس multiplied by الفيلوسيتي. إذا كنا بنحكي عن السنترويد then this is VG. okay. كمان حكينا عن الانجلر مومنتوم، حكينا عن الانجلر مومنتوم for the centroid is equal to IG mass moment of inertia multiplied by omega. Okay, or so this is one approach. The other approach we can start from R cross product M VG. okay. اوكي، وشفنا يونتس لكل وحدة ووصلنا لهذا السؤال. طبعا هذا السؤال، طبعا قبل ما نحكي عن هذا السؤال كمان شفنا انواع الموشن للريجيد بودي، شفنا ترانسليشن، روتيشن about fixed point، وشفنا الجنرال بلين موشن. في هذا السؤال ايش عندنا؟ ايش الكيس اللي عندنا؟ What do you think? This is very famous problem, okay, by the way. So this is general plane motion. Okay, so let's read the question together. ولاحظوا إنه هذا السؤال كل شابتر قاعدين نستعرض زيه. so عندنا ممكن تنويع بالحل، يعني ممكن نستعمل أي طريقة لإيجاد الحل، طبعا بالاعتماد على معطيات السؤال. إذا السؤال حدد لي حاجة معينة مش موجودة إلا في شابتر معين فبالتالي لازم استعمل الطريقة اللي في الشابتر المثل. At a given instant, the 5 kilogram cylinder bar, so this is the mass of this bar, has the motion shown in the figure below. So هذا الإند بتحرك للأسفل، as a result هذا الإند راح يتحرك بهذا الاتجاه. confined to move in this direction. بالتالي الرود or cylinder as a result بيعمل translation بيعمل rotation at the same time. Okay, so this is general motion. Determine its angular momentum. So angular momentum means H. So once he asked about angular momentum means we must benefit from equation demonstrated in chapter 19. And remember that in the data sheet we don't have any equation from this chapter. Okay. So determine its angular momentum about G and about IC at this instance. So in part A we need to find HG, and in part B we need to find HIC. Okay, and you know very well that if we need to find H about centroid, then this is equal to IG multiplied by omega. And if I need to find it about IC, where is IC by the way? So this end moves downward. Okay, let me draw it like this. Here is the velocity and here is the line perpendicular on the velocity. We have two non-parallel velocity. Remember how we determined the IC? Two non-parallel velocity. Here we have another velocity. Then the perpendicular line is in this direction. So the intersection point is IC. So we need to find H, angular momentum of this point. Okay, but as you remember that if I could draw IC, I can name this line as RA with respect to IC, and again this line I can name it as RB with respect to IC, and also the line connected IC with the centroid, we can call it, one, this is straight line, we can call it R, G with respect to IC. R. Okay. Then the resultant velocity of this point is perpendicular with this line. Okay, so I can draw, this is the direction of velocity, Vg. Okay, and it is perpendicular on this relative velocity. Ra with respect to IC also perpendicular. This one also perpendicular. So all of them must be perpendicular with the velocity. Imagine, as you remember, imagine this point is zero velocity. Okay. Now, if I need HIC, how many parameters? You must ask yourself this question. How many parameters will make angular momentum about IC? This cylinder rod will rotate, correct? Will rotate in this direction. And it has angular velocity IG omega. Okay? So the first angular momentum about IC is IG omega plus. Do we have any other angular momentum? This one. Okay? Vg. So it is M Vg. And this is cross product with R G with respect to IC. Or we write it like, if you want to write it. Do you know what? I will not write it in vector format. I'll write it in scalar format instead of writing cross product. Okay, because we know the direction already. So instead of Vg, I'll write omega R G with respect to IC. So we have 2R, then this is, and we have 2 omega here in this term and omega here. Then I'll take omega as a common factor, and we end up with IG plus M RG with respect to IC squared. Then from parallel axis theorem, this is, we call it IC omega. Okay. Refer back to this slide. So here is the general plane motion. Okay. This is the equation for linear momentum. This is the equation for the angular momentum about centroid. If we have IC, then this is the equation for IC. And here is the derivation. So either IC, I can substitute inside this equation, and instead of A, I can write IC. So I can start from here, IG plus D MVG, okay? Or this is the final result, okay? So you can imagine that this is, instead of A, it is IC. Okay. Then, this is the big picture, okay? Let us try to solve this problem step by step on the solving board. So here is the solving board, and okay, so this is the rod that we have. This point is called A, and this point is called B. This point will move in this direction, and this point has known velocity. So VA is equal to 2 meters per second. Okay, here is the centroid, and this length is equal to 4 meters. Okay, also in the picture, this angle is given, which is 30. Okay, let me use another color. It means green one. So as I mentioned, and as I am drawing in the slide, here is the IC point, perpendicular with this velocity, perpendicular with this velocity. So here is the intersection, IC, and here is the line connected IC with velocity VG, okay, and the direction of the centroid is perpendicular in this direction. So this is VG. I can write it here. Now, the second thing that you should care about is the length. So if the cylinder rod is 4 meter, okay, let me erase. So if it's given that it is 4 meter, then we can know easily this length and this length. So this length, this one, let me name it X, is equal to 4 cosine 30. Okay, because the cylinder rod is given, so using calculator, 4 cosine 30 is equal to 3.46, and this length again, the same, 3.46 meters. Okay, which this length represent R A with respect to IC. Okay, now this length again we cannot easily, I will name it Y. Okay, and this Y is equal to 4 sine 30, which is 2. So this length again is 2, and it's equal to RB with respect to IC. Okay, so if this length is 2 and the centroid from A to centroid is 2, okay, then this length again is 2, okay, and this angle is 60, this one must be 60, and as a result this is 2, okay, or you can look at it from another triangle. So if this angle is 30, then this angle is 30, okay, and this length again must equal to this one, okay, or you can take, so this angle again is 30. But the most important thing is this length, which is 2. Okay, this 2 will equal to whom? Sorry, the drawing become very crowded. So this 2 is equal to R G with respect to IC. RG with respect to IC. Okay, let's continue. So let us first find the first requirement. So the first requirement is to find HG, or angular momentum with respect to centroid, which is equal to IG multiplied by omega. Now omega is unknown. How we can find omega for this cylinder? We start from the most given information, which is point A. So I know the velocity of point A. So velocity A, using relative velocity equation, is equal to velocity IC. I'll start with the definition, but you can make a shortcut. Equal to relative velocity V with respect to IC, and you know very well that this point is equal to 0, its velocity, and this is equal to omega multiplied by R A with respect to IC. So omega is unknown. R A with respect to IC, we could find it, which is 3.46. Okay, and velocity A is given. So omega will equal to 2 meter per second divided by 3.46, and this is equal to 2 divided by 3.46. This is equal to 0.578. I will take 3 digits. Rad per second. If I know omega, then I can go directly and solve the first requirement. So Hg is equal to the cylinder rod. If you go to uniform shapes, you will find that the mass moment of inertia passing through a centroid is equal to 1 over 12 mass multiplied by L squared multiplied by omega. Okay, and this is equal to 1 over 12. Mass of the cylinder rod is 5 kilogram multiplied by length of this rod, which is 4 meter, multiplied by omega, which is 0.578. So if I use my calculator again, then this is 0.578 multiplied, 0.578 multiplied by 5 multiplied by 16. This is 3.853, and the unit for Hg is, what do you think? It's Ig multiplied by omega. Then this is kilogram meter squared over second. Okay, so this is the first requirement. Now the second requirement is to find H for Ic, which is equal to Ig multiplied by omega, okay, plus R G with respect to Ic multiplied by M multiplied by Vg. This term is equal to whom? Is equal to Hg, which is 3.85. We could find it in the previous word. Plus. Now this length, we could find that this is equal to 2 multiplied by mass, which is 5, multiplied by velocity of the centroid. Still unknown. Okay, but this value is already calculated, which is equal to 3.85. Now how to calculate Vg? Vg of the centroid is equal to VIC again. I'll benefit from IC plus Vg with respect to IC. This term is equal to 0. Then we have omega multiplied by Rg with respect to IC. Then omega equal to, sorry, not omega. Then Vg is equal to omega, we could calculate it earlier, which is 0.578. Okay. Multiplied by the distance between IC and G, which is 2. Then, using calculator again, 0.578 multiplied by 2, this is 1.156 rad per second. Okay, if I go back to HIC, then it's equal to 3.85 plus, this is Ig omega or Hg, plus R, which is 2, multiplied by 5, multiplied by velocity 1.156. Then this multiplied by 10 plus 3.85. Then the final answer is 15.41 kilogram meter squared over second. Okay, let's check the slides. So here in the slide, this is Hg, which is correct, kilogram meter squared per second, and HIC equal 15.4 kilogram meter squared per second. And here is very important the direction of angular momentum. We said earlier that the direction is in the same sense of angular velocity, okay, which is clockwise. I write it earlier. Okay, but we can find it through the cross product in the relative velocity equation, this one. Okay, or the previous one, when we find VA, which is known, equal to omega cross product RA with respect to IC. So you can judge the direction of omega easily. Okay, so please refer to the book and try to solve more problems on this section, section 18.1. Let's see the other section, section 19.2, which talks about principle of impulse and momentum. As in the case of particle motion, chapter 12, principle of impulse and momentum for a rigid body is developed by combining the equation of motion with the kinematics or kinematics. Okay, we combine the equation of motion with the kinematics. The resulting equation allow a direct solution to problems involving force, velocity, and time. Okay. So وكأنه هذا السكشن بحكي لك إنه أنا هذا السكشن راح أضم كل أنواع الأسئلة اللي أنتوا تعاملتوا معاها وأخذ لكم إياها in one equation. So we have one form of this equation. We call it linear impulse, linear momentum equation. Linear impulse refer to this part, and linear momentum, which is L1 and L2. Okay, linear impulse, which is force multiplied by time. Okay, if force is constant, then force will come out of this integration, and then force multiplied by delta T. And please notice that L, F, and L2 are bold, which means we can write this equation in x direction, and we can write it in y direction. Okay, or instead of writing L in this form, we can write it MVG1 and MVG2 state. So this is state 1 and this is state 2, and here is the change of force with respect to time. Another equation is the angular impulse, angular momentum equation. So angular impulse, this term, mass moment multiplied by delta T, and angular momentum, this is Hg1 and this is Hg2, and instead of Hg we can write again Ig multiplied by omega plus summation integration mg delta T. If m is constant, we can take it outside of this integration. The previous relations can be represented graphically by drawing the impulse momentum diagram. So here is the impulse momentum diagram. As I told you before, we have this force in x, y direction. This is bold. Okay, again, this force can be transferred to x, y. This one again, x, y. Okay, this represents the path of change from 1 up to 2. Okay, this diagram represents the state 1, and this represents state 2. In the middle, this one represents the path transforming from state 1 up to state 2. Okay, so anything with respect to force can be written in the x direction and y direction. Okay, but regarding the momentum with respect to time, this is angular, and it is about the third axis, which is z. Okay, so we have force about y, about x, and we have the momentum about z direction. Here the same. The linear momentum is about x and about y. Okay, we can transfer it to x and y, and the angular momentum. Okay, we can you can notice that this is about z-axis. Here the same is state 2. The linear momentum with respect to xy and the angular momentum with respect to z. Okay, so angular momentum and angular impulse always about z-axis. So وكأنه بنيجي بنحكي هذه المعادلة. Yes, it is bold every term. Okay, but it's about z-axis. And this equation, each one bold means vector. It's about x and y only. So instead of represent those equations in terms of diagram, okay, so this is state 1 plus state 1 to 2, the path equal to state 2, okay, or I can write it in terms of equation. So using a scalar equation for 2D problem, okay, so here is the x equation, here is the y equation, and here is the z equation. Okay, and please notice that here we have linear momentum plus linear impulse equal to linear momentum. Here again linear in y direction, impulse in y direction, and this is linear momentum in y direction. This is linear or angular momentum about z direction. This is angular impulse about z direction again, and this is linear momentum about z direction. Okay, so this is explain the transforming from diagram to equation format. Okay, procedure for analysis. Establish XYZ inertial frame of reference. Draw the impulse diagram. So here we must assume the positive directions as usual. For example, you can adapt any directions positive. Draw the impulse momentum diagrams like this one. This is the diagram. You should write it. Okay. Compute the mass moment of inertia about the centroid. Apply the equation of impulse momentum. If more than 3 unknowns are involved, because we have the equation x, y, z, kinematics equation can be used. Equation relating the velocity of the centroid and the angular velocity should be used to furnish the addition equation. Okay. And here is a second problem. Do you know what? I'll delay solving this problem until next lecture, but I need from you to solve this problem as bonus task. Okay, bonus test until next lecture. So today is Tuesday. On Thursday, I expect that you'll submit this test. Okay, so whenever at the instance I upload the video on Thursday, you will not take any bonus. Okay, so try to solve it. If not today is Tuesday. If not today, try to solve it on Wednesday. Otherwise, I'll upload the next lecture, then you lose your chance to get bonus. So try to solve it. How to solve it? Record the video and upload this video on YouTube or anything. Okay, and send me the link. Until then, stay safe.